Okay, this is the answer key for the chapter 1 practice test, starting with the multiple choice. So first question is asking which of the questions below about some students would allow for a collection of categorical data. So always good when you're reading the question to underline or circle kind of what's important. So we're looking for which one is categorical data. Remember, categorical data is a question like, what's your favorite color? You're fitting into a category, right? So I'm looking for which question fits into a specific category. If I'm looking at how many VHSs, that's going to give me a number, right? So that's numerical. What are the heights? Or height are a number, a value in centimeters. So that's going to be numerical. How many? How many? That's a key word right here. That's going to give me numerical data. Have dogs. What are the favorite flavors? Okay, so see the similarity between favorite flavors and favorite colors. You're fitting into a category. All right, so it's going to be D, and then E. What is the number of students with most siblings? Again, I'm looking for a number, so that's the hint is numerical. So it must be D. D is categorical. Okay. A local preschool finds the mean number of tardies its students had in 1 year was 15, with a standard deviation of 7. Which of the following is correct interpretation of the standard deviation? All students had between 2 and 29 tardies that year. No, that's not true. Okay. The number of tardies per student is exactly 7 away from the mean. Nope, that's not true. The difference between the mean number of tardies and the median number of tardies is 8. That's not true. We don't know what the median is. 1.5 times interquartile range of tardies is 7. No, that's not what that means. We don't know the interquartile range. The number of tardies per student typically varies by about 7 from the mean. That is true. Okay. So 15, if we think about this visually, the mean is 15. That's in the center. And the standard deviation is 7. So you go 15, and then you're going to have 22 over here, and then 8 over here. And remember that about 68% of the data is with a 1 standard deviation. So that's why this is true. Typically, we're about 7 away from 15. Okay, number 3. A lamp store recorded the number of customers who made a purchase out of a sample of 100 customers who entered the store each day. The box plot shown summarizes the recorded data for 1 year. Based on the box plot, which of the following statements is true? The range of the number of students, the range of the number of customers making a purchase is greater than 32. That is not true. So the range is the maximum minus the minimum. So that would be range here would be 32 minus 7 because my max here is 32. My minimum is 7. So that would be 25. That's not greater than 32. The interquartile range, the number of students making a purchase 25, that is also not true. So the interquartile range is this distance right here. Okay, so that's going to be 26 minus 11, which is 15. So that's not true. See, the number of days that had from 11 to 26 customers making a purchase is equal to the number of days that had at most 14 customers making a purchase. So let's look at this visually. So it's saying 11 to 26 right here has the same number as 7 to 14. This is true. This is true because each one of these segments represents 25% of the data. So from here to here, that's 25%. This is 25%. This section here is 25%. And this section here is 25% of the data. So from 11 to 26 is 50%. And from 7 to 14 is also 50%. So C is correct here. Let's just read the others. The difference between the median and the lower quartile for the customers making a purchase is less than 2. That is incorrect. That would be 14 minus 11, which is 3, so it's not less than 2. And then E, the number of days that had at least 26 customers making a purchase is greater than the number of days that had at most 11 customers making a purchase. So 20 had at least 26, that would be this section right here. That's saying that's greater than the number of days that had at most 11. that is not greater, they are equal. That's 25%. That's 25%. Anyway, the correct answer is C. These are incorrect. Okay, last multiple choice. The weights of an adult female Russian blue cat are approximately norm distributed with a mean of 9 and standard deviation of 2. So always helpful to draw these out when you get questions like these. So you're going to draw the normal curve. You're going to put 9 in the middle, and then a standard deviation of 2. Which the following is true. So about 95% of adult female Russian blues weigh between 5 and 13 pounds. Well, we remember from the 68, 95, 99.7 rule that 95% are within 2 standard deviations from the mean. Like this section here, this is 95%. So on this one, 7 is 1 standard deviation below because the standard deviation is 2. 5 is 2 standard deviations below. And 13, so that 11 is going to be here, and 13 is going to be here. I'm just adding 2 each time because the standard deviation is 2. So it's asking between 5 and 13. That's this area right here. That is minus 2 standard deviations to positive 2 standard deviations. That is true because 5 is 2 standard deviations below, 13 is 2 standard deviations above. Therefore, that represents 95%. Okay? All right, moving on to the free response. So here's a two-way table. The first question asks you to fill in the marginal frequencies and the relative frequencies. So again, this right here, this is a marginal frequency. This is just the total of the row, and then here is the total of the column. Okay, so first one, I'm just adding these together. 593 plus 836. Okay, what is that? See here, 593 plus 836 is 1429. 374 plus 630 is 1004. 836 plus 630 is 1466. And 593 plus 374 is 967. Then to find the relative frequencies, you're going to divide this number here by the grand total. So right here, I'm going to put the total of everything, which is I can add either these two or I can add these two. Let's do 967 plus 1466. That's 2,433. So my relative frequencies are just this number here divided by my grand total. So it would be 1,429 divided by 2,433. That is 1,429 divided by 2,433 equals about 58.7%. Okay. And I can do the same. I'm repeating the same for each one of these, right? 1,004 divided by 2433 is 41.3%. This one here, same thing. 1466 divided by 2433 is about 60.3%. And then 967 divided by 2433 is 39.7%. Okay, so A is done. That's all the marginal and the relative. Next one, what percentage of subjects got the flu and were vaccinated? So got the flu and were vaccinated, that is 593, but I'm looking for the percentage. So you do 593 divided by the total, 22,433. That equals 24.4%. Okay. C, what percentage of those not vaccinated got the flu? So when you say, when it says percentage of those not vaccinated, it means I only care about the not vaccinated people. So I basically, you can imagine almost covering the vaccinated row. So not vaccinated got the flu. So got the flu and not vaccinated, that's 374. So it's going to be 374. But since you're only considering those not vaccinated, you're not dividing by the grand total 2433. You're dividing by just the number that were not vaccinated. So it's 374 divided by 1004, and that equals 37.3%. And that is a conditional frequency because we give the condition that they're not vaccinated. Okay? That is question 1. Question 2. For the following questions, use this information. The distribution of scores in a recent test closely followed normal distribution with a mean of 22 and a standard deviation of 44. So always good, guys. Draw it out. Draw the normal curve. In the middle, put 22. And then the first question is, and I actually marked to the side, okay, SD equals 4, mean equals 22. So I know, like, I'll give you points if you just write something like this, okay? Now I'm looking for the proportion that scored at least 26. So 26 is going to be right here. And when it says at least, that means you're going to shade the region to the right of that because I want at least means that amount or greater. So this is the region I'm looking for. To find this region, I need to know how many standard deviations 26 is from 22. Now I know the standard deviation is 4, so 26 is 1 standard deviation above 22. So since I know this is 1 standard deviation above, you're then going to use that empirical rule that says that, if you recall, 68% of the data is between 1 standard deviation of the mean. Therefore, right here, 16% is greater than 1, right? Because remember, the total has to add up to 100. 16% is on either side. So this is just 16%. Okay. What proportion are within 14 and 30? Same thing, draw it out. Again, points just for drawing. Middle, 22. Between 14 and 30. 14 below, 30 above. Then you got to convert to z-score. So if you think, you can see this visually, 30 is 8 above 22. And since the standard deviation is 4, that means we are 2 standard deviations above the mean. Likewise, for 14, we're 8 below 22. That means we're 2 standard deviations below the mean. Okay, and if you recall from the empirical rule, this is a 68 and 95, 99.7 rule, that within 2 standard deviations of the mean is 95%. Therefore, the answer is 95%, because 14 and 30 are 2 standard deviations away from the mean. This area is 95%. Okay. What is the z-score for a student who scored 26? Okay, so the formula for a z-score is the value minus the mean over standard deviation. So you're just plugging these values into your formula. So my value here is 26. My mean, which I wrote up here, is 22. And then my standard deviation, sigma, is 4. Now you just plug it in. So we're going to do 22 minus, 26, my bad. 26 minus 22 divided by 4. 26 minus 22 is 4. 4 over 4 equals 1. So the z-score equals 1. Okay, that is part 1. Okay, this is part 2 of the practice test. We're looking at a stem and leaf. This is question 3. We're looking at a stem and leaf plot. of a family reunion, and these are the different ages. So, but essentially, again, a reminder of how to read this. This is like the first digit of the number. This is the second digit of the number. So we have a 1 year old, two 1 year olds, two 2 year olds, four 4 year olds. We have three 10 year olds. We have two 25 year olds, and so on. So again, this is the first digit. This is the second digit. Okay, and that's, you can see that in the key there. So describe the distribution of ages by describing the important features. So remember that this is essentially a histogram on its side. So if you think of it visually, what this gonna, I'll draw it to the side here. Visually, what this kind of looks like is you got kind of a tall one, and then a couple like this, and then kind of like this, and then this, this, this. That is visually kind of what this looks like if I turned it. So we want to describe the shape of this. So it is one hump, right? One kind of visual hump. So it's the shape is shape equals unimodal. But notice that it, if we can, you can kind of see it better in the box plot itself, that our peak is over here to the left. Our peak is here, and then it shallows out as we move to the right. Right, this is actually a little higher than I drew it. So that means we're actually having, because it stretches to the right, this is a right skew. All right, so the shape is unimodal plus right skew. That's S shape. Outliers, I don't see any outliers from this, right? So 63, 66, you can maybe argue that those are strays, but they are attached to distribution. I would not say that they are outliers. Be none. The center is next. So center of the data, you can find the median, which you can estimate or you can count to find the exact number. We have two. This is 2 plus 5, 7, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, plus 1, 2, 3, 4, 5, 6, 7, 8, 30, 39, 40. So I'm counting 42 total ages, total people here. So the median or the center is going to be about half of this. So 21 in. So this right here is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So we're about here, about 20, 25 or so is our median, around 25. About 25 years old is about the median. Okay. And then the V, the variance, that's the spread of the data. Okay. So we go, you can for the time being, you can sort of talk about the range. So our highest age is 66 right here, and our lowest age is 1. So we can talk about the range being 66 minus 1 equals 65. So we have a range of 65. Okay. Question 4. Robin works as a server in a small restaurant where she can earn a tip from each customer she serves. The histogram shows the distribution of her 60 tip amounts for one day. Use it to answer the questions that follow. So describing the distribution, similar thing. So we can see here, because it stretches out to the right, this is a right skew. And it looks like we actually have an outlier here, because see how this is not part of the distribution. This value right here looks like we have an outlier around $20. Okay, outlier around $20. One of the tip amounts was $8. If the $8 tip had been 18, what effect would this have had on the mean? So all this is saying is like this. Let's say this is like or no, it's gonna be over here. This is like my $8 tip right here. You can imagine this is like an $8 tip. What if we change that to be an $18 tip? That's the question. So if we did that, what effect would the increase have on the mean? the mean would increase, right? Because we can tell just visually by looking at this, the mean is probably somewhere around like the $5 mark. So since you're moving an amount to a higher value, the mean would increase because one value increased, right? That's how we calculate the mean. We add them all up and divide, right? What effect would it have on the median? So remember, median is the order. So the effect that it has on the median depends where 8 is in the order. So we can see here, okay, we have 25, 22. The median is somewhere in here, right? The median is about looking like it's about $2.50 because this is where the majority of our data is. So 8 is already above the median, right? I'm gonna show this kind of visually here. The median, the middle of the data, we have a bunch of data points, right? We have some zeros and one, and it kind of continues. Right in the middle, we have about $2.50. I can tell that just by looking at the distribution. And then we would sort of continue, and we already have this $8 here, right? And then it's going to continue. And then we have $20 at the end. So if I move this $8 to $18, since it's already above the median is not going to change. So median will not change because 8 is already above median. Okay. Question 5, last question. This is cumulative frequency. So recall in cumulative frequency, on the left side, you're essentially getting your percentiles from here. And this is just your value in minutes. Okay, let's talk about what these are asking. Q1, the median, and Q3. So Q1 equals the 25th percentile. The median is the 50th percentile. And Q3 is the 75th percentile. So all you have to do here is find those percentiles on the left and match them to minutes on the right. So the 25th percentile, that's 2 is right here, 3 is here. So you're going to match this across, go down, and so it looks like it's about 2.2. For 50th percentile, you go across, you go down, it looks like it's about 4. So the 25th percentile is 2.2, the 50th percentile is 4, and the 75th percentile looks like it's about 4.5. And that's it.